This is part 3 of the Earth's Resources topic. It's GCSE AQA Chemistry Dual Award, and therefore Triple Award students will need to know this as well. In the last video, we looked at how we treat water so that it's safe to drink. In this video, we look at what happens at the other end, where wastewater goes back into rivers and streams. I'm going to recommend that you pause and have a go at the activities as you go. So we are looking at how wastewater is made safe to go into the environment and the relative ease of obtaining potable water from waste, ground and salt water. Just a little fact there that any water that you're drinking today, each molecule is likely to pass through the bodies of 7 other people. You won't need to know that. Now, the process itself, we have sewage arriving at a pumping station. It then goes through a screen. It goes into primary sedimentation. And from there, we get sludge. That can then be digested anaerobically. And we've got some different options here where we can make fertilizer or biogas or solid fuel, or it could go to landfill, but ultimately it can generate electricity. The alternative, it can go through aerobic digestion, followed by secondary sedimentation, then treatment with chlorine or ozone or UV before it goes into the river. Let's take a look at some questions. Have a go at these. So the process looks quite complicated, but it's actually very simple. What might be removed from sewage in the screening process? Remember, screening process is stage 1. And we can parallel this with what we did with making water fit to drink as well. It removes large solid objects. It will get rid of grit. So we're starting to scale down what's in the water that we want to go back into the river. In primary treatment, sludge is separated out. It can be treated, but it then proves very useful. How? Well, we saw on the diagram it might be a fertilizer or it might be a source of renewable energy. After this, the watery liquid left, the effluent, might look clean. But it isn't clean. Why? Again, I hope you're seeing parallels here with the method by which water is made fit to drink. It contains bacteria that we can't see, but that can cause harm. In secondary treatment, we deal with that through biological processes. Microorganisms break down aerobically using bacteria. What do we mean when we say something is aerobic? So it's a good keyword that we need to be familiar with and ready to use. It means that it's happening in the presence of oxygen. Why might we then undergo further sedimentation? We want to make sure that the wastewater is safe enough to be discharged back into rivers, so we might need to go through further sedimentation to get rid of more waste. Sometimes if water is passed back into a river with a very delicate ecosystem, you can see it here, we might filter it again and sterilise using chlorine. We have got a problem with that because chlorine is a toxin. Chlorine is toxic itself. We don't want to put chlorine into river water. And also, we don't necessarily put chlorine gas in. It might be organic chloro compounds. So we've got a couple of key words here, or a key word and a key piece of information. How does chlorine gas exist in the atmosphere? Well, there's 2 ways of looking at it. The one that I'm aiming for here is it's a diatomic molecule. Chlorine exists as Cl2, chlorine molecules held together by weak intermolecular forces. Can also talk about it being a pale yellow or green gas. What do we mean by organic compounds? Again, if we go back to the crude oil topic, you're hopefully familiar with it. It's carbon-based compounds. Methane, ethane, propane, butane. Ethene, propene, butene, etc. Alcohols, carboxylic acid. It's all carbon-based compounds with 2 notable exceptions, carbon dioxide and carbonate rocks. So let's finish off by looking at how sewage sludge is treated. This is a sewage treatment plant. We've got a river right next to it because that's the ultimate source of what's leaving from there. When sewage sludge is removed in primary treatment, it's dried and can then be used in a variety of ways. How might farmers use that dried sludge? This was mentioned earlier in the video. We could use it as a fertiliser. It can be digested anaerobically below the surface in the treatment tank. We spoke about aerobic earlier. What do we mean by anaerobically? In the absence of oxygen. Couple more questions for you. At high temperatures for 30 days, the sludge is broken down to produce methane, carbon dioxide, and hydrogen sulfide. We call this mixture biogas. What might be useful? How can we use it? Well, we can use it to generate electricity. It might be that we generate electricity for the very local area, or just for the sewage plant itself. Or it could be that we take the methane, we extract the methane from it, and that can then become part of the national gas supply. And to finish off, sludge can be dried into cakes and we can burn those to generate electricity. What's the advantage of generating electricity in this way? It's a carbon neutral process. We're not putting any new carbon dioxide into the atmosphere. So we're not building up CO2 levels. That takes us to the end of this video. Thank you for listening and goodbye.